Hey, welcome back. Next we need to consider what factors influence the capacitance of a capacitor. So I've redrawn so we can kind of get an idea of the 3D space here. So we're going to have these two plates, and these are flat plates, square plates that are kind of coming out of the page or coming out of the screen towards you. And then they're separated by a distance d. Each plate has some area a, and then these represent wires that are connected to the capacitors. So if we're trying to charge up our capacitor, we're going to be interested in this value capacitance. And capacitance, again, to calculate that, we do charge divided by the voltage, or it's a ratio of the charge that each plate acquires compared to how much voltage difference we have between these two. We can think of this voltage as being like how powerful a battery we have to use to move these charges into place, or how powerful a battery we are using anyway to move this amount of charge into place. So in order for capacitance to be large, we really need to get a lot of bang for our buck in terms of how much charge separation we get and how much voltage we have to use there. Sorry about the phone. So what then, if we're going to try and maximize capacitance, is to try and get a lot of charge on each plate without having to do a huge amount of work to get them into position. So, factors that are going to influence that. First off, the area of this plate. The bigger the area is, the bigger area we have to spread out these charges. And remember, charges of the same type, they don't want to be close to each other. So it takes a lot of work to pack a whole bunch of charges into a little tiny area. So if the area is big, they can spread out more, and it's easier to put those charges in place. The second thing that's going to matter is this distance d. So let's say I put a bunch of charges on here, and we'll say we'll make this one really positive and this one really negative. And I want to take another positive charge from outside here somewhere, and I want to move it into place over here. Now that's going to be tough to do because I have all these positive charges here. But it's made a little bit easier by the fact that I have these negative charges over here that are attracting it in that direction. Now they're farther away than these positive ones, so this is a smaller effect. The positive charge, it doesn't want to get there. We're still going to have to do some work to make that happen. But because these negative charges are there, it's going to be a little bit easier. And it turns out it's even easier if these negative charges are closer. So if we minimize this value of d, then our capacitance increases. Now there's one last factor that matters, and that's something called the vacuum permittivity, also the permittivity of the material that we put between these two, if there is something there, if it's not just empty space. And so that's, well, it's more complicated than I can really wrap my head around, but we don't really need to have a super thorough understanding of what the permittivity of free space or vacuum permittivity means, as long as we can use it in our calculations on this step. In general, that's not a good thing to do, but it's tricky. There's a lot of high-level math and tensors and scale. I don't know. There's a bunch of crazy stuff that goes on to describe what the vacuum permittivity is. Do a Wikipedia search for vacuum permittivity the next time you want to have your mind melt a little bit. Anyway, we find that the capacitance C, is equal to this epsilon naught, which is the vacuum permittivity, and that's just a constant, the value of which is on your constant sheets. And then it's directly proportional to the area, so we can get more charges into a bigger area, so that's an increase in capacitance, divided by the distance. So as this spacing decreases, these negative charges, they're closer over here, so they're pulling this one a little bit more strongly, and it's easier to get this extra positive charge over here than it would be if these negative charges weren't there or if they were farther away. So capacitance is equal to the vacuum permittivity times the area of the plates, make sure that's in square meters, divided by the distance, and make sure that's in just meters.